Hello everyone and welcome to Coding Cart. So in our previous session we have solved this problem hatch path in directed graph with the help of both DFS and BFS method. So today we are going to solve the same problem in undirected graph. So for this I have taken one simple example from the LeetCode. You can see here the problem. Find if path exists in graph. So here they are not going to pass any graph to us. They will simply pass the edges of the connected graph, source and the destination. Now we have to build a graph from our end first, then we have to apply our logic. So let me take this example only and explain each and everything in details. So for example, suppose we are given a graph like 10, 20, suppose here 30, 30 is connected to both 10 and 20, and 1 is suppose 40. Now see, suppose this is a graph which is undirected graph. Now suppose our source is 10 and destination is 40. So by seeing the diagram you can see here, we can directly reach to 40. One is this direction, other is this direction, right? But how to build this graph? They are simply passing the list of edges to us. For example, for this given graph, the list of edges will look like 10 is connected with 20. So 10, 20 one list, 20, 30 will be another list, 30, 10 will be one list, and one list will be 30, 40. And they are simply passing this list to us. And this is one input for us, and another is the source, for example 10, and destination is 40. So first input, second input, and third input. So they are passing these three parameters in the valid path method. You can see there they are passing the list of edges, source and destination. So what we have to do here is our very first target will be to build the graph first. Build the graph. So once the graph is built, our next thing is to apply the logic, right? So we have already written the logic for the directed graph. Directed graph, we have written the logic in our previous two sessions. So here the logic will be quite similar, but there will be slight change because we have, if you see here, 10, 20, 30. If this is the graph, and if we are starting our search from here, if this is our source node, then we can move forward either to 30 or 20. Okay, now suppose we have moved to 20. We started from here and we moved to 20. Now from again 20, either I can move towards 10 or towards 30. Now if I'm moving towards 10, so you can see here this 10 is already visited. This 10 is already visited. So again I'm going towards 10. So if this scenario continue, then we will be in infinite loop. So what we have to do here, in this logic, we have to add a logic for the visited nodes. So this is one extra thing. What we have to do, we have to keep the track of the visited nodes. So once we are done with these two things, then we are okay. So let us go and write the logic. For example, if we are given a, let us take the same graph, 10 is connected to 20 and 30, and 30 is connected to 40. Suppose this is our graph. So what will be the edges for this graph? List of edges will look like 10 is connected to 20. So this will be one list. 20 is connected to 30, one list. 30 is connected to 10, one list, and 30 is connected to 40, one list. Okay, and this will be under a list. So this will be the edges. Okay, so we will be given this as an input, and suppose source equal to 10 and destination equal to 40. Now will be our input. From this input we have to write our logic by building the graph and applying the logic for that visited nodes and all. So let me write the code and I will explain each and everything in detail. So let us write the logic here. So they will pass the list of edges. So let us take edges equal to list of edges. So the very first edge is 10 comma 20. So we are taking this graph as example here. So 10 is connected to 20. Again a list 20 is connected to 30. Again another 30 is connected to 10, and also 30 is connected to 40. So this is the edges they will pass. Now we are given the edges. Suppose source equal to 10 and destination equal to suppose 40. So we will pass this in our calling function only. So let us call the function has path or not. Okay, in which we have to pass these edges. Suppose source is 10 and destination is 40. So we have to write the definition over here for this function. Let us define has path or not, in which we have to pass source and destination. We have to accept these three things over here. Okay, so from here we are calling the function by passing the edges, source and destination. So this is my function. Now in this function what we are going to do is we will simply write another function to build the graph. So let us call build graph, in which we are going to simply pass the edges. So once the graph is built, we are going to save this in the variable graph so that it will look like the previous codes. Like here we have. So once the graph is built, we are going to save in a graph variable so that when we print the graph, it will look like this one, like the previous one in which we are passing directly the graph. So now we are calling the build graph. So let us define here. So let us define here build graph, define build graph, in which we are passing the edges. So edges is the list of, so edges here is the list of list. Now we can simply write the logic here for building the graph. So the very first thing here in build graph is we have to take one variable graph, which will be a dictionary. After that we are going to use a for loop, since it is a list of list. So we are going to iterate in these edges one by one. So for edge in edges, so you can see here this is my edges list. So let us copy here. Let me comment out and paste here. So in each iteration we are going to get a list which will have only two values, means two nodes, two connecting nodes. So this is the edge between node 10 and 20. Again next iteration we are going to get 20 30, again 30 10 and 30 40. So what we are going to do here is in each iteration we are going to get a list which will hold two values. So let us take two values in point A and point B. Point A comma point B equal to ed edge. It means, let me explain here. Each time we are going to get here, in each iteration we are going to get a list 10 and 20 in the very first iteration. So we are going to save this in point A and this in point B. Again, in the next iteration, we are going to get 20, 30. So we will save this in A, this B. Okay, so this is node A, this is node B, node A, node B in each iteration. And after that, we have to apply the logic. What we are going to do here is, now let me explain you. Suppose this is 10, 20, and 30. Okay, so we have one empty graph. Now we are given 10 and 20 first. So this is point A and this is point B. Now what we are going to do here is, we will take this point A as a key and point B as a key of this graph. Now since this graph is empty, so what we are going to do here is, now what we will do here is, we will take this point A as a key and point B as a key for this graph. So what we will do, we will assign this 10 as a key and its value will be an empty list in which what we are going to save is its connected nodes. Again point B is not present in this graph, so we will take this 20 as a key and assign an empty list to save all its connected nodes. Now this 10 is connected to 20, so we'll assign here 20, and for this 20 is connected to 10, so we'll assign 10 over here. All set. Now next time we are getting here 20 comma 30. So 20 comma 30. So this will be my point A, this will be my point B. Now you can see here this point A is already present in my graph, which is 20 is already present, so we are not going to do anything. And point B, which is 30, is not present, so let us assign here 30 and give a empty list. Now for this 30 we are going to put the point A over here 20. Okay, and for this 20, if it is already present, then keep the point B as a value, append this one over here. Okay, so you can see here it will look like this, the graph will look like this, the graph will look like this. Now next one is 30 comma 10. So 30 comma 10. So this is my point A and this is my point B. So point A and point B both are present in my graph as a key. So what I am going to do here is, for this point A as a key, keep this as a value in point B. So 30 will keep this in a point B. So point B is 10 here. So for this as a key, let us keep 30 as a value here, and vice versa. For 30 we will keep 10. We'll keep here 10 as a connected one. Now next is 30 comma 40. Next is 30 comma 40. So this is my point A and this is my point B. Now you can see here point A is already present here, but point B is not present. So point B will be as a key and empty list will be assigned as a value. Now for this 30 we are going to keep the point B. For point A as a key we are going to keep point B as a value, and for point B as a key we are simply going to keep point A as a value here. Simply vice versa, means if both are connected, so one time we are going to keep point A as a key and value will be point B, and again point B will be key and its value will be point A, vice versa. So you can see here our graph will look like this. After build, our graph will look like this for this graph. So we'll write the same logic which I have explained you here. So first is, we have point A and point B. So we are going to check if point A not in graph. If it is not in graph, if point A is not present in graph, what we are going to do here is, we will assign this as a key in the graph. So graph of point A as a key and we'll assign an empty list. Okay, and same thing for point B. If point B not in graph, if it is not present in graph, then what we have to do, we will assign this as a key, point B as a point B as a key, and assign an empty list. And what we have to do, in a key of point A, assign the value point B, and in a key of point B, assign the value A. Let me explain one more time. Since 10 and 20 we got in the very first iteration, so our graph was empty. So what we did, we first check, is 10 not in my graph? Yes, not in graph. So 10 will be a key and an empty list will be assigned. Again 20 not present in graph, so 20 will be key and empty list. Now the next thing is what we will do. For this key 10, we'll assign here a value 20, and for this 20 it is connected to 10, so we'll keep here 10, vice versa. So what we are doing here is, since the graph was empty, so we have kept 10 and 20 as a key for the graph, and we have assigned an empty list for both. So 10 was connected to 20, so for key 10 we have assigned 20, and 20 was connected to 10, so for key 20 we have assigned 10 as a value in that list. So we will do the same thing. So for here, so for graph, for key which is point A, we'll simply append. So graph of point A means we are at 10, key 10, which will give me an empty list. So for that, go and append the value in that list, go and append the value point B. All set. And for graph at key 20 means point B, so this will again, for this key 20, again it will return an empty list. So for that, go and append the point A. For key 20, go and append point A. So we are done. This is the logic. So this loop will execute each time. So next time we are going to get 20 comma 30. So for 20 comma 30, let me explain you here again one more time. So it will look like similar this one which I have just explained you. So now my graph is looking like this. 10 is having 20 and 20 is having 10. Now next value is 20 and 30. Next value is 20 and 30, right? So again, this is my point A and this is my point B. So 20 is already present, so we are not going to do anything. 30 was not present, so 30 will be here with an empty list. Now what we have to do here is, in this graph, for key 20, go to the value part and add the point B. So go to the key 20 and its value is this list and add here 30. Okay, so for point A we are done. Now for point B we have 30. So for key 30, go in the dictionary for key 30 and add point A, which is 20. So it will look like this. Now 20 is connected to 10 and 30 is connected to 20. So it will look like this. See, 10 is connected to 20 and this 20 is connected to 10 and 30, and this 30 is connected to 20. Now in the next iteration we will get 30 comma 10. So you can see here both the point A and B are present in my graph. So for this 30, so now you can see here both the key, 30 and 10 both are present in my dictionary. So the very first two if condition will not work. It will directly jump to the next one, in which for the key 30, go to the key 30 and add point B. So in this list we are going to append 10 and for 10 go there and append 30. So 30 will be appended here. So now you can see 10 is connected to 20 and 30. 10 is connected to 20 and 30. 20 is connected to 10 and 30. 20 is connected to 10 and 30, and 30 is connected to 20 and 10. So for this graph, we are done. So this will look like this. So we have written the logic for building the graph. So this is the logic to build the graph. And at the end, what we are going to do, simply return the graph. So we are done here. We have written the logic to build the graph. So this will be returned here. Now we are done with the graph building. So what is our next task? Next task is to apply the search logic. So let us write one method here. Now we got the graph. Now the next thing is we have to write the search logic. So let us define one method. Let us define here. Define one method like. Let us define a method like path search. Path search, which will accept the graph, source, destination, and one thing is here I have discussed like, since this is undirected graph, so we have to take care of the visited node. So we'll take one visited data structure that I will explain you here what we have to take. Since the visited nodes will be the unique, so here we will be taking a set data structure. So here we are going to pass the visited. So let us, so here we are passing one extra parameter over here. So let us call this one. Let us call path search, in which we are going to pass the graph which we have created, the source, the destination, and let us pass a visited which will be a set, a new set. Let us pass a visited variable which is a new set. So we are calling this path search by passing the four parameters. One is the graph we just created, the source, the destination, and we are passing an empty set in which we are going to save the visited nodes. Okay, so we are calling from here. Now what we have to do here is we have to write the logic. Now the logic is very simple. The very first if is if our source equal to the destination, then what you have to do, return true. So if source equal to destination, so we are going to return true. So one condition is done. Now next condition is, so here one condition is done. Now every time while calling this function path search in a recursive way, every time this source will be changed. Okay, so we have to check here if this source means on the node which we are standing is, if it is already visited, then we have to return false. If this source in visited, if it is present in visited set, we are going to return false, means we are breaking the infinite loop, so return false. Otherwise if it is not present in the visited set, so simply add this source in the visited. So visited dot, add this source. All set. If the source is present in visited, we are simply turning false. If it is not present, so we are going to add this in visited, means we have already visited this node. Otherwise we have to write the simple logic for the same logic like this one which we have written here, calling recursively. So we write the same logic like here. So let us copy this one and paste here, since we already know the logic. So for neighboring graph of source, we are calling the path search function. So let us call this path search function, which we are going to pass graph never, destination, and visited. One parameter we have added here for keeping the uniqueness of the visited nodes. Now, if path search, we are calling this function recursively by passing the neighbor of each source node. So if it is returning true, then we are going to simply return true. Otherwise, we are going to return by default return false. So that's all for this problem. And so that's all, we are done. So let us run this one. So we are going to call from here has path or not. So it will first go here has path or not. It will first create the graph, means build the graph. After that, we are calling this path search. And here, once it is being called, so we have to return the returned value to the line number 41, the calling function. So let us run and check. So you can see here a path exists. So it is returning true. Now let us give here 50. Suppose source is 10 and destination is 50. It means this 50 is not present anywhere, but we are checking. So it should return false. So you can see here it is returning false. So we are almost done. So I hope you understood this solution. So simply let us copy this one and paste over there. So we have written this build graph logic. So let us copy this one and paste here, paste here. Okay. So build graph is done. After that, path search. So path search logic is here. So we are done. And next thing is, and we have to call this build and return path. So let us add here in the beginning. All set. So they have defined the method valid path, in which they are passing the edges, list of edges, source and destination. So here we are calling a build graph method, in which we are passing the edges to build the graph. After that, we are calling the path search, in which we are writing the logic for searching. So we are done. So let us run and see it is working or not. Indentation error is there. So let us clear this one here. Let's run this one. Okay, so here it is saying local variable build graph refers before. Okay, here we have to call this method here with the self keyword here. Self we have to use here, self, and here we have to give here self by default, and here also self. Again one more time here. Okay, we have missed the indentation over here, so it should come here in this position. So let us copy this one and keep here in the same alignment. So let us run this one. Okay, it is saying, okay, let us change here source with the name src and destination as the ES. So you have to take care of these variable names and all. So you can see here it got accepted. Let us submit this one. Means we are used to of SRC and DEST. So you can see here it got accepted. So I hope you understood how to proceed this problem. So the very first task was to build the graph. After that, we have to apply the path search logic in which you have to take care of the visited nodes. So that's all for this problem. And also while submission, you have to take care of the variable name and the proper indentation over here. So that's all from my end. So hope you have understood this problem in a very simple way. So if you learned something new, please do like our videos and subscribe to our channel Coding Card and stay tuned for the next video. Thanks for watching.